Welcome back to another episode of the Data Science with Machine Learning program. So in the previous session, you would have been initiated to the basic workflow which you're going to follow in our machine learning and data science course with a brief introduction to model building and data analysis using the IRIS dataset. Today, we are going to have a good look into the coronavirus statistics dataset and try to understand the various factors and regions which have been affected and impacted by coronavirus. So keep in mind, this is a changing data set, and the one I'm using is pretty old. You might be exposed to an updated data set which has a different numbers. So let's take this exercise as a way to understand how to analyze data, extract interpretations from it using the data science and Python tools which we have. So let's get started. So we have in data science, you have make good use of various libraries. You have NumPy for linear algebra operations. You have pandas for data processing and file input output operations. Matplotlib and Seaborn are for data visualization operations. So let's hit Shift Enter to get it running. And here we are defining a function. So for those of you familiar in Python, you must be understanding what functions are. And for the uninitiated, I highly urge you to take a good look into my Python course. I'll provide the link in the GitHub link below to understand in detail what functions are. So let's get started with the data. So we'll read the data. Okay, we have the COVID data set here and see the head. Head means nothing but the first 5 elements of your data set. So you have the serial number, the province, the country, the last update, which is on 22nd Jan 2020, the confirmed number of cases, the number of deaths, and number of recoveries. Let's get the information. So we have totally 368 entries, of which for the given columns, we have 368 normal for serial number. The province and state have 302 normal objects, country 368 all the way to recovered 368. So we have a few empty values here, 66 to be precise. Get to the descriptive statistics of the data set. So what the data.describe does is it identifies the continuous variables in your data set to identify the descriptive statistics for each of them. For example, you have the serial number, the confirmed cases, the number of deaths, and the number of recoveries. And you have the count, the mean value, the standard deviation, the minimum or the least value, 25th percentile, 50th percentile, 75th percentile, and the maximum value. Go ahead and to data.describe with include O. All right. So what this does is to include certain important numbers under this observation. So you have count for province, country, and last update. So as you can see, these aren't continuous variables, rather they are categorical variables. Categorical variables can point out non-numeric variables or date time variables. So you have the province, which is nothing but the region which is under observation, the country, and the last update date. Right, so here are the numbers. You have province as top, first province is Taiwan, first country as mainland China, and the last update is 29th January 2020. Okay, so there's one important operation which needs to be performed upon date for objects which have to be converted to date time. So I have the function in pandas known as date time. What this function necessarily does is it takes the single column from your data set which points out to a date type or date like information. You parse it using the pandas.toDateTime function to convert it into a datetime object. Right. So let's just quickly have a good look into what this does. Dot head. Right. So all of this is now converted into a datetime object. Similarly, what we are now going to do is from this particular column, we are going to extract the day and hour using the lambda functions. So what a lambda function does is you apply a transformation upon each and every variable in your column or pandas series by defining a function here, right? So X is any variable in the last update column, which is being converted to its corresponding day equivalent. Similarly, we are repeating the operation for hour. Now that we are done with transforming the day and hours into respective columns in the data set, we are now going to plot the variation of the confirmed cases with respect to the day on a global basis. All right, so this is our days in the month of January between 22nd Jan to 29th Jan. And as you can see clearly here, there is an increasing trend in the cases of the coronavirus impact. All right, so there's an exponential rise observed in the number of victims of coronavirus with time. Similarly, let's do a seaborne bar plot. So, okay, so 27, 22, 23, 24, all the way to 29. So there is an exponential rise, as you can see here, as indicated by these bar lines. Now let's go ahead and perform an in-depth EDA. So we have aggregating the data using the group by operation, which you might have seen in SQL, by the column country, all right, and dot sum. Dot sum points out to the summation of the various numeric variables, which we point out to confirmed cases, the number of deaths, the number of recoveries, and these two do not make sense, so let us just ignore them, right? So let us do something better. Instead of that, let's just ask the data frame to point out any certain numbers. And this looks much better. So you have Australia, Brazil, Cambodia, China, Finland, France, Germany, Hong Kong, all the way to Vietnam and United States of America. As you can see here, there's a huge variation in the number of cases. As you can see, in the month of January, all countries apart from China and Japan have reported very few recoveries in the coronavirus pandemic. All right, so you have US here 26, Vietnam 14, Thailand 61, Taiwan 32, and so on. Okay, so I have pointed out key observations from this group by activity has that mainland China has non-zero values for recovery and deaths, and that can be explored later by creating a separate data frame. So this points out to a very interesting case of observation, as we have a lot of examples and data points to understand from. And there are some countries with zero confirmed reports, right? So for example, you have Philippines, Mexico, Ivory Coast, which have absolutely zero confirmed cases of the coronavirus. So let us drop these columns, right? So here confirmed cases is equal to 0. So what we are doing here is we are applying a filter upon our pandas data frame, which points out to the number of confirmed cases at 0. And correspondingly, you have the output data frame indicating 0 confirmed cases. So let us have a look into what are these unique cases that have 0 coronavirus cases. So you have Gansu, Heilongjiang, Hong Kong, Inner Mongolia, Jinan, Qinghai, Shangaxi, Tibet, and so on. In China, having 0 confirmed cases. Moving on, within mainland China, you have many regions which have 0 confirmed cases. Similarly, Philippines, Malaysia, and a particular empty region in Australia, Mexico, and Brazil too have 0 confirmed cases, including Ivory Coast. So it is interesting to note that there are many parts of mainland China that have not been affected by the coronavirus yet. For example, you have Tibet and Qinghai having absolutely 0 cases in the coronavirus pandemic as of 23rd January 2020. All right, so let's shift enter. So what we are now doing is we are trying to understand the cases that have absolutely non-zero values for the confirmed cases. So we are not going to worry about the regions and countries which have 0 confirmed cases, but rather push our focus onto regions and countries where there are non-zero or more than 0 confirmed cases, right? So let us put a bar plot to understand the same. Using the seaborne bar plot, we have the countries that have non-zero confirmed cases. You have Japan and China, United States, Japan, Thailand, mainland China, Hong Kong, Macau, Taiwan, all the way to Finland, having varying amounts of confirmed cases in the coronavirus pandemic. Right? So the graph shows the fact that we all know that the virus has affected mainland China the most. However, there are also victims reported in other countries, suggesting the virus is spreading. There are also reports confirmed in countries that are very far away, like the US, Thailand, Japan, etc. It's a wonder how the virus got there. So, moving ahead, let's try to understand the province at state with the confirmed cases. So, this might be a pretty big graph. You're using the Plotly Express to print this graph. So as a data scientist, I prefer Plotly over the traditional plotting libraries such as Matplotlib or Seaborn. But that's a simple preference which I have from my end. But as a beginner, I strongly urge you to spend some time playing around with Matplotlib and Seaborn before moving ahead to Plotly, right? We're having a similar graph which represents regions with the confirmed cases of coronavirus, and the added benefit of Plotly is we can slice it out to a given region and understand what is its trends. For example, let's say Hubei and Henan are having a lot of cases. So how we do it? And yes. So this is one of the ways to understand data and interpret them using Plotly. Here the province and the confirmed counts. Similarly, let us build a temporary data frame having the grouping of data by province and the number of uh, confirmed cases. Right. So similarly, repeating the same activity, we are plotting the same using Matplotlib. As you can see here, there isn't much difference between Plotly Express and Matplotlib, just that the interpretability and the user experience is much different in both the cases. Okay. Now that we have understood the counts and the number of confirmed cases across different countries and regions in the coronavirus pandemic, we will go ahead and plot a pivot table to understand the growth in each country individually. All right. So we have different countries having represented by different lines and the day in January between 22nd to 29th and the count of cases. So as you can see here, the first one is definitely Australia, which is a huge spike in cases in just 1 week between 22nd to 29th of January. And the other countries are plotted down here, which exhibit a pretty similar trend in the coronavirus confirmed cases. Let's see the outbreak province-wise. Repeating this above activity, we have the province-wise outbreak. So the one in yellow has the highest spike and the rest are in red down here. So from the observations in the graph, it points out to Hubei in China, which seems to be the most badly affected province, and the reported cases show an increasing trend, which points out to the worsening of the condition. So let us have a good look at the countries that were affected initially and the countries to which the coronavirus has been affected now. Okay, so let's group by day 22 with unique country. So on day 22, the countries that have been affected are China, United States, Japan, and Thailand. So let's keep the starting day as 22nd January. Right, reports were found in China, USA, Japan, and Thailand. Now let us group by the country and plot a bar plot of it for the date number 22. Right. So as you can see here, the top 4 countries that have been identified, China has a huge spike in cases on day number 22, followed by Japan, Thailand, and the United States. Now, moving on, let's see the latest data, which is day 29, and see how the impact has varied. So we have a lot of countries that have now been affected on day number 29. So let's put a plot repeating the above activity. So China just over eclipses most of the cases. So let us put in a filter such that the data of mainland China is not shown because it definitely eclipses the other countries. Yeah. You notice a huge difference so that we have Australia, Cambodia, all the way to US and Vietnam captured in this uh, bar graph on just filtering out mainland China. It was done because the numbers of mainland China were too enormous and they overshadowed the numbers relating to other countries. Okay, now let us deep dive and get into the analysis of only mainland China, right? So we are going to filter out the data only for mainland China, and we're going to get the number of deaths, the number of confirmed case ratio, which is 2.4, which is nothing but 2.4% of the victims of coronavirus in mainland China are susceptible to death. And more similarly, let's see the recovery rate. So the recovery rate doesn't look impressive yet, as only 1.87 people percentage of patients succumbing to coronavirus have been able to recover as of now. So let's see where the region or the province where most deaths have occurred. Right. So we're going to group by the province and state by taking a summation of deaths by sorting the values in a descending order by putting the ascending is equal to false flag. So you have Hubei as in the highest number of deaths and the other provinces as follows. Right, let's plot the number of deaths here on a varying basis across the entire data. Right, so we have it from 0 on day 22 and shorted it all the way to almost 175 on day 29. Let's understand a pivot plot. Right, so we have different regions in mainland China plotted here. So mainland China values are confirmed, columns are province data, and indexed by day. Right, so we have the Hubei province having a huge shoot up in cases, with the other provinces too following the same. Looking at the same, let's plot the same for all the provinces in the data sample which we have, and it doesn't look good. So this is one activity which we had to do to understand two things basically. One is EDA, how to use Python tools to in data science to understand the data, especially we did filtering operations and a few key data frame operations to help you understand data frame accessibility better. So this was just a humble effort from my end to gain some insights into the havoc caused by the coronavirus and anything new that can be explored, and let me know if I have missed anything. So this is the data which I've been able to access between 22nd of Jan to 29th of Jan. So I understand the numbers are varied as of now in the future. So just keep me posted into various breakthroughs in data science on the coronavirus pandemic. That will be of great use. So signing out, that's it for today's session. Please let me know if you have any doubts and have a great day. Thank you.